4. Because of limited funds, 5 research centers are chosen out of 8 suitable ones for a study on heart disease. How many choices are possible? All right, so again, we are trying to figure out how many possibilities there are here, okay? So just to kind of make this a little bit more relatable, I went and I looked up on Google the best or the top heart hospitals in the United States. And so I'll write down what I found. I'll write that over here. So doesn't matter to the problem, but it might help you when trying to figure out if this is a permutation or a combination. All right, so number 1 was the Cleveland Clinic. Number 2 was the Mayo Clinic. Number 3 was Cedars-Sinai Medical Center. Number 4 is New York Presbyterian. Number 5, Massachusetts General. Number 6, Mount Sinai Hospital. Number 7, Brigham and Women's Hospital. And number 8, UCLA Medical Center. Okay, so like I said, on the Google, when I Googled this, this is the site that I pulled up said these are the top 8 heart hospitals in the country. Okay, so again, if you read this problem, it says because of limited funds, 5 research centers are chosen out of 8 suitable ones, okay, for a given study on heart disease. So let's pretend that these are our 8 suitable places that we're going to look at for this study, okay? So the funds are limited. You can't choose all 8. You can only choose 5 of them, okay? And how many choices are possible, okay? So again, we need to figure out, is this a permutation or a combination, okay? Obviously, we are choosing out of 8 things, okay? We have a group of 8 things total, and we're choosing them in groups of 5, okay? So is it a permutation or is it a combination, okay? I'm just going to randomly pick 5 of them, okay? Let's say for the study, they end up choosing the Mayo Clinic, Massachusetts General, Brigham and Women's, Cleveland Clinic, UCLA, 1, 2, 3, 4, 5. Okay, so that's 5 of them, okay? So think about the 5 that I've highlighted. If I change the order of these 5 particular hospitals, okay, it doesn't change anything. It's still the same 5 hospitals participating in the study, okay? So one more time, I highlighted 5 of the 8 hospitals that I had written down, okay? If I change the order, okay, of the 5 hospitals that I highlighted, so for example, if I do Brigham and Women's, then Massachusetts General, then UCLA, then Mayo Clinic, then Cleveland Clinic, it doesn't change the 5 hospitals that are in the study, okay? So order is irrelevant here, okay? So order does not matter, okay? This is going to be a combination, okay? So we're doing a combination out of 8 centers. We are putting them together in groups of 5, okay? We're looking at all the different ways out of the 8 total hospitals that we can arrange them in groups of 5, okay? And again, the order doesn't matter because if you have a group of 5 hospitals and you change the order, it's the same 5 hospitals that would be participating in the study, okay? All right, so to compute this, we can apply the formula, okay? So if we go back up here, okay, to our box, okay, here's the formula for combination, okay? It's n factorial over r factorial times n minus r factorial, okay? So this 8 is going to be our n, and then 5 is our r, okay? So this is going to be 8 factorial over 5 factorial times 8 minus 5 factorial, okay? So this is going to be 8 factorial over 5 factorial times 3 factorial, okay? So we're going to get, I'll write this out in the numerator. It will be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay. In the bottom, okay, I'm going to go with the larger number first. I'm going to write down 5 factorial and line it up appropriately so things will cancel. And then I also have to multiply by 3 factorial, okay? And then I'm going to cancel stuff out. So the 5s go, 4s, 3s, 2s, and 1s, okay? So in the numerator, I'm going to be left with 8 times 7 times 6, okay? So let me go and figure that out. Okay, so 8 times 7 times 6, okay? That's 336. The denominator is going to be 3 times 2 times 1, that's 6, okay? So if I figure out what is 336 divided by 6, that's going to be 56, okay? So there are 56 different combinations of 5 hospitals that can participate in the study, okay? Again, I promised you, okay, to show you how to do this on the calculator, okay? So now we're going to enter in a combination. Remember, you can call this 8 choose 5. Okay, so if I go back to my calculator here, you have to put in the 8 first. Okay, at least on an older calculator, you have to. I think maybe on a newer one, you can just go and pull up the combination. Okay, so in case you have an older calculator, I'm going to do it this way. So I'm going to enter in the n value, which is 8, then go to math, okay, go over to the probability menu. Option 3 is for a combination, okay, and it converts it to what looks more like the notation, okay. So now we need to enter in the R value, which is 5 here, okay, and we get 56, okay. So going forward, like I said, I am perfectly fine with you doing permutations and combinations on the calculator. That is fine. You do not have to plug it into the formula at all. Okay, you can just, my thing is, can you figure out, is this a permutation or a combination? That is more about what I'm concerned about. Okay. All right, so that was the end of this particular problem. Okay, 56 different combinations of putting these hospitals together in groups of 5 for the heart study.